All right, we'll go ahead and get started. My name is Pradeep Kumar. I'm the organ chair for the Communication Society. And this event is co-hosted with us by several other chapters, namely the Seattle chapter, San Francisco, Central Texas, Buenaventura, Foothills, Orange County, Albuquerque, Sacramento, the Chicago, and Orange County. So keep it to the point here, and I will now introduce Ralph Vanathambi, who will moderate the call. Ralph Vanathambi is an IEEE fellow as well as a researcher with research manager at Intel Corporation, and I will let him introduce our keynote for today.
Right. Thank you, Pradeep. I'm very happy to introduce our speaker, Dr. Edith C.H. Ngai. She's an associate professor in the Department of Electrical and Electronic Engineering at the University of Hong Kong. Before joining Hong Kong University in 2020, Dr. Ngai was an associate professor in the Department of Information Technology at Uppsala University in Sweden. Her research interests include IoT, edge intelligence, smart cities, and smart health. Dr. Ngai co-authored papers that received Best Paper Award in QShine 2023 and Best Paper Runner-Up awards in ACM, IEEE IPSN 2013, as well as IEEE IWQOS in 2010. Edith was an area editor of the Internet of Things Journal from 2020 to 2022. She's an associate editor in IEEE Transaction of Mobile Computing and IEEE Transaction on Industrial Informatics. She has been a TPC co-chair in IEEE Smart City 2025, GreenCom 2022, and IWQOS 2024. Dr. Ngai was a project leader of the Green IoT in Sweden, which was named on IVA's 100 list of Royal Swedish Academy of Engineering Sciences in 2020. She received a Meta Policy Research Award in Asia Pacific in 2022. Edith is a distinguished lecturer in IEEE Communication Society from 2023 to 2024. That basically helped us, find her for this presentation. I spoke with Edith. She said it's okay to interrupt and ask questions if you have. So unmute yourself and ask questions. If too many questions comes, we will postpone some of the questions to later. So without any further ado, let's welcome our speaker.
Thank you very much for the invitation and a very nice introduction, Ralph and Pradeep. Really appreciate. Yeah, so let me share my screen.
Yeah, we can see.
Great, wonderful.
Oh,
okay,
nice.
good. Yeah, okay, great. Yeah, so today I will talk about artificial Internet of Things for smart cities. I actually have been working on this topic for quite many years, maybe close to 10 years. Yeah, so today I will actually highlight two of the projects that I have been working on. One in Hong Kong is still ongoing, and then one was in Uppsala, Sweden that has already finished. Yeah, so this slide shows the vision of artificial Internet of Things. So I believe many of you might be familiar with this idea already. So, maybe more than 10 years ago, we have been working on IoT. Yeah, so we talk about wireless sensor networks and how the sensors can be connected together, and then they communicate and they collect data, and then it helps us to understand more about our environment, so we can sense different things like air pollution or traffic or whatever, like human activities as well. And then through these things here, like smartwatch, wireless sensors, and even now we have smart vehicles, autonomous cars. Yeah, and then we get a lot of sensor data And then with a lot of big data analytics and artificial intelligence techniques, then we can turn this data into some information. And then it gives feedback to the public, to like policymakers, the business units, or just system administrators to do a lot of smart decisions, which can optimize the performance of those AIoT or IoT systems, and then can give feedback to the environment or the human behavior. Yeah, so there are so many applications could be supported by AIoT. Yeah, for example, this talk we focus on smart cities, right? I will give you two examples. So the first one would be about air pollution monitoring in smart city. And then the second one more inside our house. Yeah, so it would be it's about smart water auditing. So I will tell more about that later. Yeah, so coming back to AIoT, so other than smart cities, actually we have a lot of other applications as well. For example, a lot of people work on smart health nowadays. And then and AIoT is also very well known for industrial IoT systems. And we have intelligent transportation systems as well. Yeah, so there are a lot of opportunities actually using AIoT and machine learning nowadays. Yeah, so if we look at smart cities, so what are the most popular or common applications? So here it actually is a picture showing Hong Kong. So Hong Kong is a very, very dense and busy city. So you see a lot of high buildings. So we have many office buildings and residential buildings, which are very, very tall with many floors. Yeah, so actually a lot of AIoT systems have been implemented to optimize the lighting, the air conditioning, and also the property management, like even the water consumption have been monitored and built, and people have been very concerned about the electricity consumption because it could be quite costly. And we have other urban infrastructures like traffic lights and some urban parks. And they are also installed with a lot of sensors. So recently, I heard that a sister university in Hong Kong actually invented some sensors for detecting the health of the trees. Yeah, because the trees, if they are too old and they may fall and they may hit the cars or people. Yeah, so there are sensors being developed to just check to make sure the trees are healthy, and so they will not fall. Yeah. And then we have a lot of other things like recently we have vehicles can do autonomous driving, and then there are so many sensors on the cars. Yeah, so these are all the applications that we already seen in smart cities. So today I will give more examples. Yeah, so focusing on two research projects that I worked on. The first one is called the Green IoT. Yeah, so it was conducted in Uppsala, Sweden, before I returned to Hong Kong. And then another project that's more recent. Yeah, so that's the Smart Water Auditing project that I conducted in Hong Kong. Yeah, so you can see from the pictures already. So basically, Uppsala and Hong Kong are two very different cities. So in Uppsala, yes, the buildings are much lower and not that tall. And then we live in a very spacious environment and a lot of green. Yeah, but people are still very concerned about sustainability and the environment. And on the other hand, on the right-hand side, you see Hong Kong is so crowded and so dense with a lot of people and buildings everywhere. Yeah, so of course, we still have pollution problem here, or maybe even more serious. Yeah, but this time the project that we start with is about smart water auditing. So we have more interest in like the domestic water consumption in-house, and we want to see how people consume water and how they use the water in different categories, cooking, bathing, etc. Yeah, so let's talk about the Green IoT project first. Yeah, so it started quite long ago. I think around maybe 2015 already, and then it lasts for 3 years, around 3 years. Yeah, so the project goal was to develop an integrated solution based on IoT for air pollution monitoring for smart cities. Yeah, so at that time, if you think about 10 years ago, maybe the AIoT term was not there yet. Yeah, people still talk about IoT. And then we have a lot of things to do, like developing sensors, make sure they can communicate, and then we can collect the data reliably in smart cities. And then we start using more machine learning algorithms to analyze our data. Yeah, but at that time, I believe, if I remember, yeah, like those deep learning models still not that popular like nowadays. Yeah, so a lot of things we still use like some maybe more traditional statistical machine learning techniques and support vector machine and other things. Yeah, to start with, yeah, analyzing the data. But it doesn't really matter. I think it's just like the development of the technology, right? Yeah, so this project was quite large at that time. Yeah, so we involved like many institutes, including Uppsala University, KTH, and SIX. Yeah, so SIX actually was a Swedish institute in computer science, and then later on it changed name to RISE. Yes, and then it covered more institutes. And Uppsala Commune, that's the city of Uppsala. So it's actually quite important to get the support from the city when we want to conduct projects related to smart cities. The reason is that we need to understand the problem, first of all, and then we may also need to install a lot of sensors on the city infrastructure. So we need to get like the permission from the city. And then it involves, the project involves a number of companies like SenseAir, which is good at developing sensors for air pollution monitoring. And then we involve Ericsson, IBM, and they are interested in like the cloud computing part at that time. And we have two other smaller companies, For Dialog and Upwiz. So For Dialog is good at developing visualization tools, and Upwiz is again another IoT system company. Yeah, so at that time, the architecture was still quite standard. Yeah, so we have some sensors that we developed, and then we will deploy them in the city later on and collect data. And the data will be sent through the sensor gateway to the cloud server, and then we can store the data in the cloud and process the data. And the goal is to serve the data for the city administrators and also some general public. So there are some high-level outcomes, like we want to make it real and practical. So it's not like we just do it in the lab. After testing in the lab, actually we deploy the testbed in the city. So our original goal was to enable larger scale air pollution monitoring. So the reason is that at that time, actually in the city center of Uppsala, there was only one air pollution monitoring station. Yeah, the reason is that actually those high-end air pollution station or weather station together, usually they are pretty expensive. Yeah, that's why we do have many in a city. Yeah, so the idea is that if we can make some low-cost sensors, then we can deploy these sensors at more locations, even though the sensing quality may not be as good as those high-end air pollution monitoring station, but we can increase the coverage of our sensors in the city, so that we can understand more on like which area might be more polluted, and then we can maybe direct the traffic or plan the roads a little bit better. Yeah. So and the platform itself is collecting data, and then the data will be processed and then be able to visualize, and we want to open the standard for different users in the society, including Uppsala city and researchers and companies, and also just ordinary citizens. Yeah, so I show this on this map. Actually, is the map of Uppsala. Yeah, so here actually around this place is the city center. And then you can see that this is the King Street, and it has a lot of traffic normally. Yeah, but in the city, actually at that time, there's only one monitoring station here right at the center, yeah, on King Street. Yeah, but other than King Street, other places like this area, they are also quite polluted and sometimes even in this area. So that's why we want to put some more sensors in different locations. So not only at the city center. Yeah, so that's the motivation of the project. And of course, in the project, we spend a lot of time developing some wireless sensor prototypes. So we make use of different boards like a Raspberry Pi. To the gateway is fine and not that special. Yeah, but the sensor units, then we try different kind of air pollution sensors. Like in the project, we start with these PM sensors, those particles sensors, and then and make a lot of integration and the enclosure and the power, how to power the sensors to save energy. And this is another prototype developed together with the company. Yeah, so and we measure PM 2.5, PM 10, and some of the sensors have also NO, NO2, ozone, CO sensors. So yeah, so this is the air pollution and station, a monitoring station from the city. So it's a very expensive one. And here are the sensors that we developed in the project, and then we place it close to this station so that we can make a comparison between the readings. Yeah, because these low-cost sensors are supposed to have less accurate readings than these well-calibrated and well-maintained air pollution station. So these are the pictures when we install our first sensor in the city center. So this is the King's Street, yeah, Kunstgarten. Yeah, so and you see that actually it's quite a lot of effort to install the sensor on a lamppost. So we have to get the support from and permission from the city, and we also need to get the electricity companies help to install the sensor here. Yeah, and it disturbed the traffic a little bit as well because of this big vehicle that we used to mount the sensor. Yeah, so this project actually gave us a lot of experience knowing that it's actually a little bit different from other research projects. So if we want to install something on the city infrastructure, actually it takes a lot of time, and also it is very complicated to communicate with quite a number of related institutes, yes, or companies. Yeah, so yeah, but I think it's still very interesting, and it's a good experience that we can explore how the sensing technology can help improve like the sustainability of the city. Yeah, and you have seen the picture comparing having the sensors side by side here. Yeah, our sensors and the city's original sensors. Yeah, so we compare the readings of PM 2.5 between these two sensors. Like the KTH sensor is a sensor that we developed together with KTH in the project, and then the SLB, it is the city's sensor. SLB is an institute doing air pollution monitoring in I think in the region or even in the country. Yeah, so you can see that the trend is very aligned. Yes, just maybe the peak, then we have a little bit difference. Yeah, but it's still showing like the peak when we have the highest PM measurements during the day. Yeah, so it is actually very interesting. So the peak usually if it is in the weekdays, yeah, then you can observe the morning and the night traffic are increasing, right? Even yeah, when people go from work to home, yeah, because this is before COVID, so it's still very regular. Yeah, then we can observe some kind of a daily pattern. Yeah, but it is not only the daily pattern. Sometimes it's related to the wind and also the weather, because especially for PM, then they are particles, they are heavier, so they are actually affected by how the wind blows in the city, and then how they spread, and as well as the infrastructure in the city. For example, on King's Street, because of the two sides of the street has high buildings, then it also affect the spread of the PM, the particles. So after deploying some stationary sensors on the streets, then we also come up with an idea. So why don't we also try some mobile sensors? Say we can put some sensor on the city bus. Then when the city bus move around, then basically.
Sorry, can I ask a question?
Yeah, of
So
course.
in the previous one, you have your own like a low-cost sensor as well as the sophisticated, what is your the low-cost sensor? How does it do? How does it the results are pretty great. It's very close, but how do you how does it work? And how do you and maybe if you know how the real sensor work, that'll be also good to compare, what is the technology.
Oh, yeah. So that's a good point. Yeah, so I can give you some insights here. Yeah, so you see that here, oh, sorry, let me see if I can still have my data pointer here. Yeah, so here, this one, it is actually, this is not only the air pollution sensors. Actually, it also includes some other sensors for meteorological data. Yeah, so but this part, it will take the airflow in, and then it can measure like the concentration of different components. For example, for SLB sensor, this can monitor basically almost everything from PM 2.5, PM 10, ozone, CO, NO, NO2, etc. Yeah, but the thing is that why is it so expensive? Of course, first thing, it has very expensive sensors. But the second thing is that actually they do a lot of maintenance on these SLB sensors. So I remember they have to visit at least once a month to do the calibration and the cleaning, and maybe they need to change the filter, etc. Yeah, so this is why it is so expensive. Yeah, so from the airflow to the sensors to the calibration, the maintenance. So it takes a lot of effort. And so from time to time, we can see a small car from SLB just park next to it, and then they do a lot of work, to take care of like the sensors to make sure the readings are accurate. Yeah, but then for our sensors, so even though we also have, you see some small hole, here to track to let the airflow to come in, but maybe the flow rate is not that accurate, and also these sensors that we bought from the market and integrated here, they are low cost, and then also their lifetime. To be honest, I believe they will get less and less accurate along the time. So for example, I expect them to only work well for maybe 1 or 2 years, and then maybe in the third year we have to replace them. Yeah, so these are the major differences. Yeah, but to be honest, like the detailed operation inside these SLB sensors, I have no idea as well. I just actually did some work before, say when we got these sensors, then the low cost one, we also got some help from the Chem and Material Science department in Uppsala, and then we got into their lab to do some calibration together. Yeah, so we did the first calibration in the lab before we deploy them. Yeah, but then we don't do any more calibration. Yeah, after that. Yeah, so I believe definitely the performance will degrade from time to time. Yeah, but
and
yeah.
how about from the low cost one, the IoT one, you can get the reading continuously. It's connected, right? How about for the other one, the real one?
This one.
Yeah.
That's a good question. I think they can still get the data, but not quite sure if probably they can still do it. I think they can get it remotely, I guess. Yeah. Even though they visit the sensors very often, but I don't believe they use a memory stick to copy, because they also have a pretty nice database for storing this data, I guess.
Right.
And since this is a very big station, so I believe they can even have some internet connection. Yeah, but I'm not sure. Yeah.
I see. Okay, all right. Yeah, thank you.
Yeah. Yeah. But this is why there's only one in the city center, because yeah, it's so expensive.
Expensive.
Yeah. And for our sensors, then we use wireless communication, the 6LoWPAN, and to transmit the data to the cloud. Yeah. So for us, we don't need to bother the collection of the sensors. Yeah. But for us, yeah, the electricity could be a concern. Yeah, because for the SLB sensor, probably they definitely have this electricity supply. Yeah, but for our sensors, then yeah, we have to use the battery or the power bank. Yeah, and then the power could be consumed. And I remember that when we talked to these people from the electricity company, they are Vattenfall. Yeah, so they allow us to use the electricity on the lamppost. But the problem is that they will turn off the electricity during the daytime, so we cannot get the electricity during the daytime. So that at that time we have a power bank, and then we can charge the power bank at night, so that in the daytime we still have sufficient energy to use for the sensors.
I see. Okay. Yeah, thank you.
Okay. Yeah. So from the comparison, looks like at the beginning, yeah. So because this is at the time when the sensors are newly deployed, yeah, from our side. Yeah. So at that time we still do not experience like what we talk about, the degree of the accuracy, especially for the low cost sensors without further calibration or maintenance. Yeah, and then the other idea is that what about doing this on a bus? Yeah, so this was a very fast experiment. That's why we didn't use our prototype. Yeah, we bought actually a sensor from Libidium at that time, and then just install it on a city bus. Yeah, so from Gamla Uppsala bus, that's the bus company's name in Uppsala. Yeah, and then when the bus travel around in the city, then we get a lot of readings at different locations. Yeah, so this could be even more efficient than deploying a number of wireless sensors on the street. Yeah, but it raises also another concern, because when the bus is moving, then actually it changes also the airflow at the sensor on the bus. Yeah, so that's why again we may not have a very accurate readings. Yeah, I think the airflow is a big problem when we develop like low cost or portable sensors. Yeah, so yeah. But at least, yeah, so we can see that from the map on the right hand side, for example, then these darker color are the regions that well understood by the Uppsala city, that they are more polluted. Yeah, so because the traffic are very easy get jammed, very dense in this region. Yeah, so it somehow shows that okay, yeah, so actually we can observe a higher pollutants in these areas. Yeah, so yeah, but it's just like a pilot testing at that time. And after that, then the company like Ubis, comes up with an idea. So why don't we use like portable sensors that carried by bikes, because there are so many bikes in Uppsala. And then they developed this small thing. Yeah, and then they also did some initial study and small experiments with participants. They carry the portable sensors on their bike. Yeah, but again, yeah, so the airflow is becoming even more challenging in this small box. Yeah, so it takes a lot of validation, yeah, to make sure the readings are correct. Yeah, but it then will be very difficult. Yeah, so it means that actually after the project, so when I look back, then I believe that bus maybe it is still more manageable. So at least we can take care of the sensors on the bus, right? More easily. But for bikes, then how to maintain these little sensors by like the participants, mobile participants, then it could be more challenging. Yeah, but on the other hand, if we get a lot of readings from a lot of people, then maybe somehow we average and combine everything, then we can still like have a rough idea, overall idea how the pollutant spread in the city. Yeah, and then at that time, yeah, so we try out also different machine learning algorithms to analyze the data. Yeah, so but since the project was only 3 years, and then we didn't have sufficient data to test out our machine learning. So that's why we also get the data from the database from SLB, yeah, because they have a number of monitoring stations in Uppsala and Stockholm region. So for us to have more testing. Yeah, so we use machine learning techniques, especially Gaussian process at that time, to explore like the weekly, daily, and 12-hour and 8-hour patterns for NOx concentration in urban area. And then we can see very clear periodic patterns. And like in the weekdays, yeah, people go for work in the morning, and then they go from workplace to home, and then we can see like the peak of the NOx, yeah, in the daily pattern, and then less in the weekends, yeah, because they don't need to go for work. Yeah, so with this kind of observations, then it can help us to make a more accurate time interpolation as well as predictions on the air pollution data because of these periodic patterns that we capture. Yeah, so it turns out that if we compare like the true values and the periodic and the predictions, then we can see that they are quite aligned with each other. Yeah. Okay, so I need to move on to the second project. Yeah, so the Smart Water Auditing project in Hong Kong. Yeah, so the project goal is to collect data and provide insights on how water is being used in domestic consumption. Yeah, so how much water has been used for the basin type, for kitchen, for shower, for washing machine, for example. So for toilet, it's not that common to use fresh water for flushing. So we skip this one actually eventually in the project. So why we do that? Because we found that actually many cities in the world have a decreasing trend on the water consumption, domestic water consumption, but not in Hong Kong. So that's why we want to actually study like how people use water. So how much water has been used or has been wasted in different usages. For example, is it true that we take longer shower than the other countries? That's why we consume more water. Yeah. Here again, we need to understand like the water consumption, right? Yeah, but in Hong Kong, actually a lot of, I think majority, over 90% of the smart meters, billing meters are not smart. Sorry, they are not smart. They are very traditional. So basically based on some staff from the water supplies department to visit the billing meter physically to write down or to take a picture of the the billing meter readings. Yeah, so that's why we want to make it smarter. Can we do automatic reporting of the data and also have more fine-grained measurements on the water consumption? Yeah, our objective is basically through the smart meter, and then we get more fine-grained readings on the water consumption, and then with our machine learning algorithm, eventually we can output like the distribution of water end use in different categories like showering, kitchen or bathroom basin or washing machine. Yeah, so I skip this. And this is the hardware configuration of our SMAN. So we call it SMAN, that's for integrated on or installed on top of a traditional billing meter. So it has actually two parts. This part is for the data logger, wireless communication, and also the battery. And then this part, it is mounted on top of a traditional or existing billing meter. Yeah, so it has a camera inside which can take picture of the reading and then send it and do also machine learning, and then send the reading to the cloud. So it has a camera, so we can we have a beam splitting glass, so people can still see it when the water supply department staff comes by and take the reading. Yep. On the other hand, we have also a camera that can take picture, because we don't want to disturb like how the water supply department work. Yeah, but we want to test our research. Yeah. So and we take a picture of the meter reading, and then through CNN network we digitize the record, and then we can send the record to the cloud through NB-IoT, and then we can do some data analytics and machine learning. Then we output the water end use data. So this is one example. So basically, we will get only the billing meter readings. Yeah, so it's something like this is the total water consumption at home. Yeah, but we want to do disaggregation, water end use disaggregation. So how to train this model? Of course, we need ground truth data to train the model. So when we train the model, of course, we need the tape-based sensors to do that, and I will show you. Yeah, but basically the idea is that after training the model, we can do water end use disaggregation through the machine learning. Yeah, so this is what we want to achieve. Yeah, so this part is quite a challenge. Yeah, because how to turn this total water consumption pattern into the distribution, then actually we have to conduct another pilot study. So we installed tape-based sensors in 21 households for collection of labeled ground truth data. Yeah, so install in the shower head and washing machine and the kitchen and basin type. And train the model, and after that we test out the idea, like look into the accuracy in testing. Then we see that by event occurrence means that we have so many flow events. So one flow event means that we turn on the water tape and then the water flows, and then we turn it off. Then that's one flow event. Yeah. So if it's by event occurrence, then the accuracy is, for example, this is the sensing interval, then it will be like 76.1%. Yeah, but by volume is a little bit higher. Yeah, by volume it means that we just look at the per category. Yeah, what's the accuracy in terms of the volume? Yeah, like the total water consumption in that category. Yeah, then it's a bit higher. Yeah, than the per events. So when we deploy these sensors in these 21 households, then we chose different locations. This is Hong Kong. Yeah, and we have like different density as well. Some areas are very dense, some are just high density, and some are medium. Yeah, and then in total we deployed more than 100 sensors. I remember it's like 120. Yeah, and then we use NB-IoT for data communications. Yeah, at that time. Yeah, and then we've also spent some time to test on the signal strength, the reference signal receive power, and also the reference signal receive quality. Yeah, and we find that when we have a higher building density, then the signal receive power is higher. Yeah, but if we move from outdoor to deep indoor, then it will decrease. Yeah, and on the other hand, about the quality, yeah, this reference signal receive quality give an indication on the interference. So if it is in a very high density area, then the interference will be much more, then the signal quality will drop. Yeah, it will be the same because of interference and also the penetration of the signal. Then when we are very deep inside a house, then the signal quality will also decrease. Yeah.
One question, just
Yes.
curious, why you didn't use, for an example, Wi-Fi, why narrowband IoT? Just a curiosity. One other question, somebody asked in the chat, for your previous project, what radio transmission technology you used? You mentioned something, I didn't catch it. Yeah.
Oh, okay. Yeah, so first question, why not Wi-Fi? Yes, actually we test on Wi-Fi before. Yeah, so in one of the first few households we use Wi-Fi. Yeah, but then we need to do a lot of configuration. Yeah, so we need to know like how to connect to that Wi-Fi access point from the household. Then, yeah, then and then later on, then we think that maybe it would be easier if we don't need to do any configuration and to test on NB-IoT. The one motivation behind is that eventually we will also deploy the SMAN, the part on top of the building meter. Yeah, in any places may not have Wi-Fi. So that's why let's do it in one shot and do the NB-IoT. Yeah, but I agree with you. Actually, if it is at my home, yeah, for example, then it's more reasonable to use Wi-Fi. Yeah, but for convenience for engineers, and they say, okay, I will
cheaper versus convenience and accuracy probably work everywhere. Maybe yeah, right.
Yeah.
Okay.
Yeah, and then going back to the sensing technology in Green IoT, I remember it's as 802.15. Yeah, let me see. Yeah, was it Zigbee or something like that? Yeah, at that time it was quite long ago. Yeah, but I think right now maybe less people work on this 6LoWPAN protocols in smart cities. So it looks like people are turning into more and more NB-IoT nowadays. Yeah.
Okay.
So,
Yeah. Again, that is coming back.
LoRa as well. LoRa is
Oh, I see.
popular. Yeah.
I
So
see.
I guess that one. Yeah, it's not that popular anymore. Yeah.
I see. One of the work I studied, release 19, 3GPP release 19 is ambient IoT. This is coming again, it's with almost zero power kind of things is coming back for this kind of application. That means you don't need to change the battery and all that often as today.
Oh, yeah. Right. Yeah, that's true. Yeah.
Okay. One other question in the chat is, what use is made of air pollution data? Can the city control to reduce pollution?
Yeah, that's a very good point. So at that time when we discussed with the city, so they have the city planners, like especially the traffic experts, then they would think of like giving some new policies, for example, limiting the traffic on the King Street, for example, in the peak hours. Yeah, so maybe some of the cars cannot drive into those area which is highly polluted or and then it may affect also how they build some new roads for the city later on to divert the traffic. And so that's something that they talk about. Yeah, but I believe the policy thing might be easier to implement, but like building a road, it will take like a very long time.
Right.
Yeah, so the cities was very engaged to know more about like the pollutant spread. Yeah.
Okay, thank you.
Yeah. Okay. Yeah. So here it shows a slide on traditional approach like event-based categorization. So traditionally, people will look into the flow. Yes, I mentioned the flow is like a flow refers to the water usage since water tap has been turned on until it turned off later. Yeah, and then if there are overlapping events, then they first will disaggregate the overlapping flow events. Yeah, again, this is the total consumption. Yeah, and after that, they will do the support vector machine or ANN to do the classification. Yeah, so how to capture more information? Yeah, so other than doing the traditional like flow-based event categorization, then we are thinking that we can make use of more information like the inter-event patterns. Yeah, because if we look at only single flow events, then we don't know like how the events are related to each other. Yeah, so that's why we think that, for example, the laundry cycles may consist of multiple flow events that look similar or with a higher volume. Yeah, then maybe that could be a hint for us to identify the laundry usage and also the patterns like time of the day information. For example, people usually cook during lunch hour or dinner. Yeah, then maybe it can be some additional information for us to identify kitchen use, water use. Yeah, so our idea is that other than just doing the traditional flow-based event categorization, then we can do the use UNet to do the disaggregation of the water use data. Yeah, then we do not need to perform flow event disaggregation, but we can do it in one flow. Yeah, so we just input all the total water consumption data, and then we give the time of the day information, then we can do the disaggregation. So UNet originally has been used for medical image segmentation, and then later has been used for audio source separation. Yes, so for example, you have a piece of music, and then you can separate into different channels for different instruments. And we can also use it for electricity load monitoring. And then for this project, we use it for water end use classification. Yeah, so we use the dice loss as a loss function, and then we weight all the classes equally to prevent the model bias towards the dominant classes. Yeah, and then the good thing is that UNet can capture also the correlation between events and also the time of the day information. So that's why in general, accuracy is higher than the traditional approaches. Yeah, so for example, if we input like the water consumption data, and with our trained UNet model, then we can perform the disaggregation like the figure below. But still, it is not 100% accurate, of course. Yeah, so for example, here you see that it misunderstood. The lower diagram misunderstood these are all laundry water consumption, but actually part of this in the ground truth data is from the kitchen use. So it happens from time to time. So if we compare with traditional water end use disaggregation techniques like SVM and ANN using events-based categorization, then the UNet accuracy will be much higher than them. Yeah. So it looks pretty good. So it comes to the conclusion. So in conclusion, I just present some very, I think, high-level idea at the beginning about how AIoT can be used for smart cities. And then I go into like more details and give you two examples from our previous projects, including the Green IoT project in Uppsala and the Smart Water Auditing project in Hong Kong. And both projects actually just shows that we can use AIoT systems to collect a lot of sensor data from smart cities, from air pollution in Green IoT to domestic water consumption in Smart Water Auditing. And then I can just say that at the beginning, say 10 years ago when we start Green IoT, then a lot of focus have been put into how to develop the sensors and how to make the connectivity works. For example, 802.15.4. Yeah, so at that time, yeah, the communication range still pretty short. Yeah, so maybe just 100 meters, and then after that we have to do multi-hop communication, even on the same street. Yeah, so at that time, LoRa is just at the beginning. Yeah, so we test it a little bit, but we didn't actually make use of it in the prototype. But now, if I can choose again, I would definitely choose a LoRa instead of 802.15.4. Yeah, so I think the technologies are changing. And then in smart water auditing, so we test on NB-IoT. Yeah, it's more expensive, but I think it's also convenient. Yeah. But nowadays, I believe more focus has been put on the machine learning parts. Yeah, so in our recent projects, the training of the UNet model and how to perform the cleaning of the data and to make sure the model can be generalized enough when we have new data coming in. Yeah, so these are the part that people focus more nowadays. Yeah, but still a lot of things like the power consumption, the battery lifetime, the scalability, like security and privacy still, yeah, from the beginning to now still not totally solved. So we are still working on this area. So overall, I think it's still a very interesting topic and can bring societal impacts. Yeah, so that's all for my presentation. Yeah, in this talk, so I welcome any questions and further discussion. Thank you.
Thank you, Edith. So we have time for questions. If anybody have any question, you can unmute and ask your question directly. I have a question.
Yeah, sure.
So you mentioned about that, the using AI, right? Coming up with the model and all. So maybe for the second project, using data collected and coming up with this model and all. How much of water consumption could be reduced based on your models and data collected?
Oh, thank you for the question, Ralph. Yeah, so this is actually a very good question. Actually, this smart water auditing project is still ongoing. So in the part that I show you actually is just on the technological part, like how to perform a water end use disaggregation. Yeah, so it means that it just shows you like, okay, now this is my water consumption. Then I can tell you like how much water you have spent on showering, taking a shower, or cooking, etc. Yeah, but actually in the project, because it is a collaboration with the social science faculty, and then they are more interested in how to influence the human behavior, how to make people consume less water. So recently they conduct a pilot study that they will send a letter to the participants in this project. Yeah, so later on, actually, we invited around 200 households to participate in this project, and then we will monitor their household total water consumption. Yeah, and then we will compare their water consumption per person with the average in Hong Kong. Yeah, and then for those families spend use a lot of water more than the average, then they will receive an envelope in red. Yeah, and then give them like a red flag that you need to open it, and then I will tell you what's the problem in your household. Yeah, and from my last meeting with them, they say that actually those people receiving the red envelope, some of them even call the hotline to talk to them, like what's our problem. Yeah, but not everyone. So yeah, so they are testing how to change the behavior of people. Yeah, but I think it's super interesting. Yeah, so my job is to help analyzing the data, but actually
Right.
I
Eventually the goal is to kind of optimal use, reduce at least reduce in no wastage, in other
Yeah,
words.
exactly.
Yeah.
And I
I
can
see.
give you an example. Actually, some families they install a new shower head that can save the water. So for example, they control the flow rate of the shower head so that and they will
I
not
see.
so much water. So it can help with
Right.
that kind of components. Yeah. Yeah.
I see. Yeah, that's interesting.
Yeah.
Any other questions? Anybody else? Right. We are almost at the top of the hour. If no more questions, we can thank our speaker. Thank you, Edith, for your 8 a.m. time, very early in the morning in Hong Kong. Take your time to give us a interesting presentation with a lot of practical details and all. Thank you so much.
It's a great pleasure. Thank you so much for inviting. It's really nice to have opportunity to discuss with you all. Yeah.
All right.
Okay. Yeah,
Thank
thank you.
you.
Thank you.